Hello everybody, welcome to this vlog. My name is Satya. So today we will discuss about VXLAN, why it is used and how it is the most suitable protocol technology that should be implemented in data center for scaling the data centers. So here I describe the topology diagram of VXLAN fabric. It is having lot of nodes. So to explain VXLAN, VXLAN is virtual LAN virtual extensible LAN, right? So what is the necessity of having VXLAN when we have VLAN, virtual local area network concept already available? The main drawback is VLAN has scalability issues. VXLAN is used to provide a layer 2 networks over layer 3 IP network. Now I have described what is layer 2 network and layer 3 networks previously in my other vlogs. Today, now in this vlog, I will recap that. Layer 2 network stands for communication using MAC addresses or the VLANs within the layer 2 network, right? But VXLAN does the layer 2 network but over the layer 3 IP network, right? So what I want to say is there are two important concepts in VXLAN. One is VTEP, virtual tunnel endpoint, and VNI, which is virtual network identifier. Virtual network identifier is 2 to the power of 16, so it can scale up to millions of the networks. Virtual network identifier networks basically. So VLAN only has 4096 possible networks with a VLAN provision, but VXLAN provides 2 to the power of 16, which is in millions of layer 2 networks. So what exactly when I say a layer 2 network? Now layer 2 network is usually a local area network. Let's suppose you have a broadband gateway at home. That router provides an IP address to our mobile phones and laptops. Now there might be one mobile phone and there might be more than one mobile phones in the same broadband gateway network on the LAN side, local area network side. When these mobile phones wants to communicate or share files among each other, it will not go through the broadband gateway. They will communicate through our packet saying who has this IP address, try to provide me an MAC equivalent of it, and that is provided to the source, and that's how he sends a packet to the destination using the MAC at ARP resolution, right? But it will not go to the broadband gateway. In the same way as I described in the topology here, there is a tenant A, tenant B, tenant C, tenant A. Now these are different tenants with different VNI addresses. That is virtual network ID, virtual network ID number, right? So there are two VMs, two tenants which are on the same VNI, which is tenant A and uh, tenant A at the end, right? So as you see here, tenant A and tenant A, they have the same VNI 100.1.0.100.1.0. That means they are the same local area network, right? If they want to send packet from VM A1 to VM A3, then it is over this network, that is the leaf spine network of VXLAN tunnel. Through the VXLAN tunnel, it will send the packet to VTEP 4. That means to say leaf 1, leaf 2, leaf 3, leaf 4 are the VTEPs, virtual tunnel endpoints, and spine 1, spine 2, spine 3, the green color dotted lines indicate that IBGP is used. BGP plus EVPN control plane is used for exchanging the EVPN attributes across these spine networks. Okay, so let me clarify or make it more easy to understand. So if we want to send a packet from VM with tenant VNI ID 10010 to tenant B VNI 10020, VM1 will send an ARP packet, right? So the ARP packet will come. He has an IP address of 10.20.20.11, right? So 10.10.11 wants to send an packet to 10.20.20.11. He will send a ARP packet for 10.20.20.11, which is received here on the leaf network. It will put an UDP header which is having a destination port as 4789. That is a VXLAN tunnel port, and then he will put a VXLAN header saying this is my VTEP address and I am going to VTEP address is this one, right? So now this IP routing between spine and leaf is already established using IBGP, right? They know how to reach from VTEP leaf 1 to VTEP leaf 2. Once the packet comes at the VTEP leaf 2, he will decapsulate the VXLAN header and it will send the packet to VM B1, for example 10.20.20.11. He will respond with the ARP. Now the question is, he will respond with the ARP response packet saying I'm at this MAC address. So now, will it send an ARP on these IP links? No, it will not, right? Through the EVPN control plane, EVPN attributes, they will already know the MAC address of these VMs connected to leaf 2, these VMs connected to leaf 3, and these VMs connected to leaf 4. So the ARP will be suppressed here, but they will have an ARP table for with respect to VTEPs. So for VTEP2, the ARP address for 10.20.20.11 will have this. So he will send a packet to this VTEP, right? So they will not send the ARP packet directly from VM to VM B1. They will send ARP packet, right? If the ARP packet, if the MAC address is already updated for a particular VTEP ID, then you will respond with ARP response saying this VM B1, that is 20.20.11, 10.20.20.11 is at this MAC address, and you'll send it to VM A1, which is 10.10.10.11. If the MAC address is not available, then the ARP packet will be encapsulated in the VXLAN and it will be sent to leaf 2, and then VM will respond with the ARP response, right? So the same ARP packet will not be sent. It will be encapsulated in the VXLAN packet, VXLAN header, and it will be sent, right? So to recap, VMs are the data centers where different streaming servers might be running. Like for example, YouTube has a data center. So data center has VM, and these data centers have streaming servers to provide streaming content to the end users, right? So now to reach this VM, just for example, if you want to reach VM B1 from VM A1, as I told, first he needs to resolve the MAC address, right? It is like the same layer 2 network, but over the layer 3 infrastructure which is found by leaf and spine network. So 10.10.10.11 will send an ARP packet if the ARP packet is, so if the destination IP address is already mapped to MAC address in the VTEP table, a VXLAN table, MAC address table, then he'll respond here itself. At the leaf one itself, he'll send ARP packet is responded, and you have to send the actual data packet. If you're sending a ICMP packet, send to this MAC address. If it's not there, then the ARP is encapsulated in VXLAN header with the UDP header as 47, UDP port as 4789, and the VXLAN tunnel address, that is VTEP 1, which is 10.25.1 to 10.255.1.1 will send to 10.255.1.2, right? Then again the ARP resolution should happen. That is not with respect to the layer 2 network that we are calling. So this is the underlay network, spine and leaf. Overlay network is the VMs, right? So this is how, if you want to send a packet from leaf 1 to leaf 4, which is of the same virtual network identifier, that can also be done, right? Now, what exactly we mean by route reflector? Route reflector is the one to reduce too much of broadcasts of BGP packets, BGP advertisements in a particular segment, right? So route reflector, everybody will send the routes to route reflector. Route reflector will send the routes back to the leaf nodes depending upon the routes learned. So there won't be advertisement of the there will be an advertisement of the routes between each route reflectors, right? And also the VTEPs will exchange the routes to reach VTEP 1, VTEP 2 like that through the route reflector only. So route reflector is like reflecting the routes to the underlying networks. So that is what it means. Then I will show you here traffic flow example. VM A1 sends traffic to VM B1. Frame is encapsulated by leaf 1 VTEP with VXLAN ID 10010 and 10020. Packet routed over IP underlay network, which is a spine and leaf network, and then leaf 2 decapsulates VXLAN and forwards it to VM B1, right? It returns the traffic flow the same path. So that's how we can imagine the packet flow in the VXLAN network. VXLAN networks has two components. One is spine and leaf, which is an IP underlay network, and the actual layer 2 network where the actual packet will be initiated or received. Those are called as overlay networks, and they accomplish by using the concepts of VNI, virtual network identifier, and VTEP address, virtual tunnel endpoint address, right? So the EVPN functions, the BGP EVPN as a separate attribute for MAC learning and distribution, ARP&D suppression, multicast optimization, IP prefix distribution, that is for IPv6, fast convergence, VM mobility. That means the VMs can move from one network to other network, which are from one leaf to other leaf, right? So that is easier. So friends, this is what I wanted to highlight and give an overview of the VXLAN communication in VXLAN protocol in data centers. So if you want to know more about route reflector, leaf, how it exchanges the packets at the underlay routing underlay layer 3 network, then do put a comment. I will try to explain in more detail. Thank you. Bye.